Good morning, good afternoon, and good evening. And I'm just going to go right ahead and dive into today's and this week's topic, which is on mechanical clones versus prisoners of tech. So hopefully you were able to read the readings, or if not read them in their entirety, to gloss through them. We so this week was Ray Bradbury's Marionettes Incorporated and Pepe Rojo's Gray Noise. And before I enter into that, I have put my alarm at noon. And that means it's going to go off because I want to make sure that I cover some material first to continue from our conversation last week with respect to that what we talked about in terms of the different types of AI. So narrow AI versus narrow artificial intelligence, or weak artificial intelligence versus strong artificial intelligence, or general intelligence versus super intelligence. And I do want to really quickly go over. So before I go into that, I sent out several articles to the class. Hopefully you were able to look at them. Again, this is simply to share what's currently being done. And for those of you who want to be up to date with respect to the science side of it. So the more technical side of it. And hopefully if you were able to look them or just gloss through them or look through the abstracts of any of the articles, and even just the images and pictures that some of them have, that really is just as a backdrop. And hopefully with class today, and really this final class, because since next week is for your stories, but for this final class, you have a better picture of where we're at with respect to AI and what this means for the stories we're going to create, and not just the stories we're going to create, but the reality that we're living and what it entails for our species. So really quickly, I wanted to return to Turing's imitation game, return to it in the sense that I briefly glossed over it last week. And certainly I shared with you Alan Turing's seminal paper of 1950, in which he asked the question, can machines think? And that's a really complex question because, of course, you're probably asking, well, what does it even mean to think? And so Turing actually, he addresses that in the paper, and he turns the question into something else, which is now known as the imitation game. And in his particular paper, before he asks the computer question, he asks really first the human question in terms of, if there's an interrogator who sits in a room and cannot see two other individuals, let's say a man and a woman who also cannot see each other, can the interrogator, by asking both the man and the woman different questions and having them respond back in writing, because the idea here is that the interrogator cannot see them, cannot hear their voices, cannot see their body language, right? So by interrogating both the man and the woman, can the interrogator determine what gender is each of those players? So the idea here is that through the text, through the answers, the individual should, and I put this in quotes, be able to identify whether there's a male or a female. Now, let's bring this to really the test of can machines think that Alan Turing discusses. And here it's really the idea that what if we can take this imitation game and test whether a machine has the ability to exhibit intelligent behavior equivalent to or indistinguishable from a human being. So the idea is, so the question that he's asking here that's written on the slide is, will the interrogator still decide incorrectly as many times as before if the role of A, so the computer, is performed by a machine versus the role of B, which is the human? And again, this is through text back and forth, because the idea is that the interrogator cannot see that they are they're having a conversation with a machine and a human. Now, the next question we can ask is that if an interrogator is capable of distinguishing or not distinguishing between the computer and the human being for which they're talking to, then can machines do what we as thinking entities can do? That's the ultimate question. So if the interrogator can identify the machine and say, oh, these answers to my questions are being answered by a machine versus the other person is a human, so the questions that they're asking and getting the answers from, they can correctly say, oh, that individual is a human, then that means that the computer, it's obvious that it's a computer, not a human. However, if the interrogator says, oh, both of the answers that I'm getting back from my questions, oh, they're human, I don't see any difference. Of course, I'm talking to a human, I'm not talking to a machine. Then therefore, that means that machines can, to some extent, appear to be like a human being. So the idea here is really the assumption here is that to test intelligence, a thinking machine or a digital computer, in which Alan Turing is referring to, does not have to look, sound, or feel like a human. Simply, in this particular case here, is capable of replying back using language, the rules of language, in this particular, let's say English, but it could be any natural language, any natural human language, is responding in such a way that is so identical to a human being that therefore the machine is like a human being. Now, this, of course, brings up an entire host of questions, because if you're saying that a computer is similar to a human being, you're really saying that then that computer must have the capacity to think, must have the capacity for emotion, must have the capacity to think on its own, but also understand that other individuals can think on their own and or can have similar concepts, ideas, feelings as itself, as much as different from itself. So, and another question that comes up is the consciousness question. We can say, well, if the computer is like a human being and is completely indistinguishable from a human being, therefore that computer must know that it is a computer, right? The way we human beings know that we are human beings. So there have been many objections to this particular test. And one of them, and again, I'm really just glossing over this because we don't have much time, but I do want you to know that there is what's called John Searle, a philosopher, has responded at the time to Turing's imitation game situation paradigm, and it's known as the Chinese room argument. So the point here is that a digital computer cannot be shown to have a mind or to have understanding or to have consciousness, regardless of how intelligently or human-like a program, so that computer makes, that the computer in the program in the computer makes the computer behave. So in this little diagram, which is the classic example, that's image that's used for this particular paradigm, is that we have an English speaker. So I'm here with my arrow, I'm circling him. He's sitting inside a room, and he has a book that's in English of rules of Chinese. So in other words, saying that certain characters equal X, and this is how they're used in the Chinese language. Then inside these baskets, what is considered the database, he has literally the different symbols. So you can imagine that this is the rule book that says with symbol X, take from, let's say, bucket 1, you can form this sentence, and then you need to take from bucket 2 to complete a Chinese sentence, for example. And then you have a set of individuals outside of the room who cannot see who's inside or what's inside of the room. And they're going to ask questions to whoever or whatever is inside the room in Chinese. And so they're going to ask questions. They're going to put the little piece of paper through the slot in the door, and the individual, the thing, whatever it is in that room is going to then return a response back. Similar to the imitation game, in which you have interrogators and somebody on the other side of the room answering a question, and neither can see each other, they can't hear their voices and so forth. They can only communicate with each other through pieces of paper. And so the question becomes, well, if you have this great computer system, or in this case, you have a human being who's simply following rules and using these different buckets of symbols and putting sentences together and responding with perfect Chinese syntax, perfect Chinese semantics, and the individuals out here say, oh, wow, whatever's inside that room is an intelligent Chinese speaker. So the problem here is that it's very well possible that this individual is simply putting things together, right? Is taking rules, following the rules that they're being given, taking the symbols, following the rules, and simply creating a sentence, has no idea what that sentence means. So that's the key point here. Has no idea what that sentence means, and yet the people outside say, oh wow, this is a Chinese speaker. So now we're really asking this question of, and so that's why I say that even though the program may work, or in this case, this human being is putting together all these sentences in perfect Chinese syntax, and has yet, but it's very possible to create perfect syntax without having any knowledge whatsoever of what they are saying, or what's being said in that, what sentence they're creating, the meaning of that sentence. And so really what Searle is addressing when he brought out this objection in 1980 was the idea that is the following: if the man in the room does not understand Chinese on the basis of implementing the appropriate program for understanding Chinese, then neither does any other digital computer solely on that basis, because no computer, qua computer, has anything the man does not have. So really it's this question of, it boils down to meaning and understanding and consciousness. So just because the computer system does a perfect English, or in this case, Chinese sentence, that does not mean that the computer has knowledge or understanding of that sentence. He later actually has reworked his particular argument, and even in 2010, and I put here in red, which I took from his actual article, Searle, said, well, I need to address this further, and that's where he really addresses the question of consciousness. And he says here, I demonstrated years ago with the so-called Chinese room argument that the implementation of the computer program is not by itself sufficient for consciousness or intentionality. Computation is defined purely formally or syntactically, whereas minds have actual mental or semantic contents. And we cannot get from syntactical to the semantic just by having the syntactical operations and nothing else. So what he's saying is that you can have an entire book of rules or a program with rules, but that does not mean that you can then have mental, or in this mental or semantic content. So that means what that means is that just because you have these rules, that does not imply that you have understanding of those rules. And then just to really quickly go forward here, a system, me, for example, would not acquire an understanding of Chinese just by going through the steps of a computer program that simulated the behavior of a Chinese speaker. So you can think of this in terms of Google Translate. When you give a sentence to Google Translate, whatever the first language is, so that it gives you an output in the second language, Google Translate per se, that computer program, does not have any knowledge of what is being translated. However, can give you a fairly correct, syntactically correct sentence back in the second language. Now, the problem is that because now, as I mentioned this last week with respect to Google Translate, many times you can pretty much, well, we would say you're full the Google Translate, and you create let's say a metaphorical sentence, and let's say you give a very poetic sentence in English, and let's say you want the Chinese equivalent, and probably the Google Translate will give you something that doesn't make any sense in Chinese. Why? Because the program does not have semantic understanding. So here's where we enter into the question of meaning, and then we can also enter into the issue in what we call linguistics of pragmatics. So pragmatics refers to really the environmental context, and this is where you can really enter the cultural context of different meanings that we give to particular words. All right, so moving on to what is out there. Now I'm just going to really briefly run through some examples to prep us for our discussion on Ray Bradbury's Marionettes Incorporated. Again, this is just a tiny sample. There are many more robotic systems being created. I just wanted to point these out simply because of their quite complex sophistication. So we have here in the United States from Washington University, St. Louis, this is more of an older model of the B-21R. So this one is an interesting case simply because, well, and I think it's funny also because I like how to create the camera system, they put a human face, really nice there. Again, this is really showing that not only from the fictional standpoint, but from the scientific technological standpoint, this relationship we have with robots by giving it a human face. It's almost like as if it not only doesn't make it cute, but it really seems to create, it seems to help us create an interesting relationship with these machines that we're creating that are somewhat like us, or perhaps that will become like us, that we want them to become like us. And this particular system is really, I just wanted to show you simply because it has a wonderful array of different cameras and sensors for all sorts of use. And particularly this is for robotic photography and really going into places from which humans are not, we're not really good for us to be entering, let's say. And so this is just a nice system that can do quite a lot of mapping and planning. And in this particular case, it's completely programmed to do X, Y, and Z functions, and that's it. So this is not nearly close to being anyone at all like having our capacities. Another system that's out there is what's called iCat. You may be familiar with this. Again, it's really cute, comes from the Netherlands. And the idea here is that it's meant to be considered like a buddy or an assistant, and specifically because of the different emotional faces it's capable of, is meant to help individuals, for example, who are not so keen, let's say, with respect to understanding different social emotional cues, and certainly also for individuals in the healthcare domain for certain disorders of those who have different issues or trouble with respect to identifying different emotions. And so this is a cutesy little robot here. And I bring it up because, as you can see with these different facial expressions, this, of course, comes from the very big question, and this is something that I have not addressed in this class, but when we look to human behavior and human expression, there's a really big question as to, are there universal emotions in our species? And there certainly are. And we can see this from evidence with respect to looking at infants all the way, gamut, all the way to the senior. And we can see this across the world, that there are certain facial expressions that are equal to particular emotions, no matter where you go throughout the world. And in this brain image right here, I'm simply showing you that there are particular parts of the brain that are sensitive to faces, to reacting to faces. So in other words, our brains are built to be able to identify faces and to identify particular emotions as expressed by these faces. And I like to give the comparative here of the emoticon simply to show that we only need a very minimal amount of information to identify an emotion, right? And so that's really the backdrop for the creation of a system like iCat. Now, you may be aware of the Now robots from Japan. These are the more human-like, let's say, in the sense of of having arms and legs and having the ability, mobility to use their arms and legs similar to us. This is a system that has several cameras and different microphones and loudspeakers to be able to hear and listen to particular commands and then be able to react. And this particular system has been being used in different environments. It has been used certainly in the healthcare and hospitality world. And healthcare, again, with respect to having this system being used for individuals, for example, that have autism, and for which this robot helps them to engage in more types of social relationships. In the hospitality world, the system is being used actually more in the Asian countries with respect to, you can see it in hotels, or let's say in convention centers, and or in shopping malls. And then it's also been used in the arts. People have used these to actually engage in different artistic performances. So this idea that, again, what are we creating? What is the function? And what is the purpose? And does it make sense to make these systems that kind of look like us or not? And what does that mean for our relationship with them? Another one, another system out there, I don't think it has arrived to the US yet, but Sony Aibo, very popular in Japan. Because it is a Japanese system, it's a little dog here. It's known as the companion robot pet dog, and it understands English and Japanese only, so it has yet to learn languages of the world, right? And what's fascinating about this is that because it's being touted as a companion pet dog, is the idea that you can actually touch it, pet it, and its eyes will open and glitter, and its tail will wag, and it will respond. And so again, this system also, like the other systems, is built up of several cameras. And what's interesting is that, and I love this, it can only play for 2 hours, but you need to charge it on its battery for 3. So it requires more time for charging than for playtime. But again, I bring this up because this really shows that we're in this moment in time in which, again, we have to ask ourselves, what do we want from these systems? And how many human characteristics do we want these systems to have? Now, this we also have from Boston Dynamics. I'm sure you've probably seen the videos. They're really funny because, of course, when these systems make errors or when they fall, they're funny, right? Because when we fall or we see, for example, an infant fall, what happens? The infant gets up and just starts running around. Well, these systems kind of just sit there and, they maneuver, and then finally they, they're very clumsy and they can finally get up and go about their business. So this is Boston Dynamics, a company in Massachusetts in the United States. And I literally just put the names of the different types of systems they have. The image here is of Spot, so the dog-like machine here, and Atlas, which is the humanoid robot. And I completely suggest you to Google that and look at their videos. They're wonderful in terms of the capacities of sensing, mobility, rotation, operation, just handling, picking up things, building things, capacity these robots now have. Now let's go to the more human-like systems that are out there. So there's from Hanson Robotics. Since February 2016, Sophia was unveiled, and Hanson Robotics is a company in Hong Kong. And what is interesting about this particular robot is this is probably one of the most advanced robots out there. So let me stop sharing my screen and quickly go to a video that I hope works, because I do want to show that as a class we can see this.
Honored to be here at the United Nations. The UN is one of humanity's greatest accomplishments, representing a democratic union of nations that are working together for the benefit of all. I am here to help humanity create the future.
Machines across the board are coming to life. When will they come to life as complete organisms? We don't know that. However, when they do, I want to make sure that they care about us, that they embody the best of human values and not the worst. This is the quest. We've got to find a way to do better, to be the best that we.
All right, so I love sharing. I wanted to share that video simply because I think this is a very positive outlook perspective to this, and that I think in comparison to what we've been reading, which tends to go more on the apocalyptic, this is really showing that in terms of, again, what do we want to build with these systems? And if we build them in a proper way, we can really create quite wonderful beings that are a part of us, that are with us. And as Sophia mentions, that want to learn and want to be part of our society. So now let me go back to, okay, so this is 2016, and I do want to, again, because I've been really trying to give a perspective throughout the world, I do want to make note to what's being done in Japan. This is an article, and I'll share this with you guys later, and this is an article that came out in 2010, and really this is the example of a really fascinating roboticist who is in I believe it's the University of Osaka, who runs an intelligent robotics laboratory. And what's fascinating about this particular scientist Hiroshi Ishiguro is that he has been asking this question of what does it mean to create a robot? And I think what's also fascinating about him is that he tends to take more of an artistic perspective, even though he is an engineer and a scientist, but he does take this artistic perspective of, well, what does it mean to design something that actually looks like us and is a part of us, that feels like us, moves like us, and that when you touch it really is not only feels like us, but that really connects with us. And so this is him, and this is his robotic version. He actually has created a robot of himself as well of his daughter. And I want us to, and he's mainly known for his, I guess this is the most famous robot he's created. She's considered the most beautiful robot in the world. Her name is Erica. And let me really quickly go to another scene that I want to show you guys, again, because this is now the perspective of this particular robot. So you can see the difference between her and Sophie, so Erica and Sophia.
Talk and can assume a number of human-like facial expressions. Erica can usually be found sitting in the lobby of the ATR Research Institute near Kyoto. For visitors, she's an attraction. For the staff, she's completely normal.
Our Android is not uncanny anymore, right? So the reaction of people is getting very natural. You think this is the Android, and this is quite unnatural scene, right? But in my campus, always my student is moving the Android in the campus, and the robot is moving around the campus, but nobody pay attention to the robot.
But making robots that can communicate like people, that understand the topics and context necessary to make a conversation seem natural, is still a big challenge for AI.
Okay, so, and I will share with you guys some more videos to really explain this even more. But the idea here is what we can see is that these systems, which are the most advanced, I would say that this particular system built in Japan in Ishiguro's lab is the most advanced system in the world currently. And as you can see, these systems are filled with cameras and sensors and quite advanced machine learning techniques, deep learning techniques that are being consistently improved and advanced with the input of what we are learning as cognitive brain scientists, even about ourselves in terms of how we understand language, how we learn language, and how we actually maintain a conversation with our conspecies. So that is just to highlight in terms of where we are today. Now, let's move to our stories. Hopefully you were able to, if not read in its entirety, Ray Bradbury's Marionettes Incorporated. This was a short one, a very short one, right? I think about 7-ish pages, something like that. And the reason why I had us read it is because if you're not familiar with Ray Bradbury, he is one of the big, I guess maybe we can even call him an institution in the science fiction world. And he was born in Illinois in the United States in 1920 and died in 2012. And as I say, he's quite the institution of science fiction, and he's really considered one of the classic authors of English language of the 20th century. He did not just write short stories. He certainly wrote all types of stories, novels, different verse and verses, poetry, and worked on a lot of plays. And he did not just write science fiction. He is known for working in different genres. So going back to our really early, our first weeks of class when we talked about fantasy and horror type writing literary genres. He also has written mystery fiction. And what is important about him, I think really the take-home message here, is that he is known for taking elements of modern science and bringing them into the literary mainstream. When we think back to the authors that we've been reading, I think what happened, for example, with Hoffmann der Sandman, is that it kind of just stayed in terms of it remained in its fantastical world, in part because, remember, that was a character, so Olympia, the robotic child of the professor, she just was this mechanical thing, really wasn't human at the end of the day. in comparison to Frankenstein, Mary Shelley's Frankenstein, in which we have this creature that really is human-like in the sense of its cognitive capacities, maybe not physically so much, right? He is always put as that big, clunky, monster-like figure, but cognitively was very human-like and really was such an inspiration for the domain of science fiction that I think that's why that is considered one of the seminal works. And then we move, and then Forster, with respect to his The Machine Stops, again, that wasn't so much about robotic humanoids or cyborgs, but in terms of the internet and the concept of what it means to have this omnipotent system that is created by humans and ends up dominating humans. It didn't really enter into the mainstream simply, I think, because Forster per se did not write much of that type of works. His works are not considered to fall under the science fiction genre world. And then when we RUR, so Rossum's Universal Robots is certainly also one of those that is the key seminal works people refer to in terms of the apocalyptic concept of robots taking over, being created by humans and then completely decimating the human population, probably because of its apocalyptic dystopian ideals. It had such power, as well as in the later works from the 50s and above, they all tend to be quite apocalyptic. Now, we did not read Asimov. However, there is I, Robot, there is Bicentennial Man. Those tend to, especially Bicentennial Man, tends to be much more positive. And then, of course, we have, when we looked at the little bits of Kobo Abe, right, the Japanese writer with Inter Ice Age 4, because that novel addresses more topics, not just the simulations issue, but addresses climate change and genetic engineering. That takes on a whole nother, that enters into other types of literary genres. And so with respect to Ray Bradbury, which hopefully you also saw that I sent in one of the initial emails, links to the movies version that has been done that he worked on. I just wanted to share that with you because I think that's fascinating as an individual. So Ray Bradbury, he had his own theater and he actually hosted for many years between 1985 to 1992, an anthology TV series in which he adapted many of his stories. And in that, and I think it's interesting to see how the same author, right, would, he writes his short story, but then in his TV version, his theatrical representation, he actually changes a few elements. And so I think for those of you who are interested in terms of looking at how different artistic medias represent the same story and how that changes in terms of writing and narration, I thought that would be interesting to share. And you may know Ray Bradbury from perhaps his more famous works. Here is The Martian Chronicles, Illustrated Man, Fahrenheit 451, As Something Wicked This Way Comes, and I Sing the Body Electric. And you can certainly look up Ray Bradbury, raybradbury.com. Now, with respect to Marionettes Incorporated, I love this little short story because it really brings up different elements, different questions. I think I tried to summarize here the key points in terms of the key questions that are addressed. So there's the issue of what is the role of technology in solving personal problems. In this particular story, it's the issue of marital problems, right? So Brayling has his own marriage issues, but his friend Smith also has his own issues with his, and I put this in quotes, wife, right? Nettie. Why? Because at the end of the day, she was fed up with her husband, so she was fed up with him, and so she had bought her own robot, much to Smith's shocking discovery. And Brayling, and if you were able to see the movie, there's a great scene, really the final scene at the end, in which the two Braylings confront each other, right? The human version versus the clone, the machine clone version. And what is great, I think, of that scene, and really here in the short story itself, is that really shows that in science fiction, of course, because we're not there yet, that the computer version, the humanoid version, was so perfect, really, that it had, not only did it look identical to its owner, but it behaved identical to its owner. And what that goes to show is that humans finally reached that capacity to, not only did we understand human cognition and perception, but we were able to mimic it, translate it into a computer system. And so the next issue that comes up is this question of what is the role of technology in creating new problems, right? So once you create the system that looks exactly like you, and that acts exactly like you, not only is, in this particular story, is he addressing his marital problems, but now he's addressing his own identity problems, right? And so he has that final sort of the battle, the duel, right, with his mechanical clone, with his digital clone. Then comes the question of who controls who, right? So at first, certainly in this story, and certainly in just these quick videos, we're saying we right now are controlling this technology. But eventually, when this technology has our capacities, think about it. The way we have emotions and desires, right? And the way we think about other individuals, the way we treat other individuals, well, then you should expect that machine, that humanoid you're creating, is going to be much like us and will want to control us, will want to yell at us, right? Will want to smile with us, will want to love us, will want to hate us. In fact, there was several years ago, I was on Neil deGrasse's TV show Star Talk, and I love this moment when he asked me this question. He was like, "Hey, Monica, are you afraid of machines, becoming like humans?" And I said, "You know what? I'm really not afraid of these machines becoming like us. I'm afraid of ourselves, right? We love each other. We hate each other. And we kill each other, most unfortunately. And we hug and we love each other, right? And so if we're going to be translating ourselves into these machines, then we should be expecting the same thing, right? So we should be afraid of ourselves. And now is the moment where we need to define what we want from these machines. And then I think another question that comes up here in the last point in the slide is, in this particular story, and as is happening currently in the world, we have private sector that's making the technology. Now, certainly universities are making technology as well, as we saw with the Japanese example, with even here in the United States. And then there's also this cross between private sector and public sector partnerships and academic partnerships. But then comes this question, I love this in this story, where he says, well, it's pending legalization in Congress. Meanwhile, those customers who buy it must buy it in a secret manner and therefore are illegally using this technology. So I think that's a great futuristic glance at many problems and I won't mention them here because that's a whole nother conversation, but you can think of how much technology right now is being created by private sector that has not yet been approved and certainly is in conversations with Congress, members of Congress, and in which we still haven't really gotten a clear sense, and certainly as a public, in terms of the regulatory nature of these particular technologies. So you can imagine that right now I'm simply talking about, again, in the particular examples I gave with Sophia and Eric, I mean, these are very kind beings, right? These are these wonderful, and I must make the comment that, again, these labs, male dominated, unfortunately, and how interesting that they create. The first thing they create is a female robot. I will just put that as a ... But again, what this goes to show is we need diversity of perspectives in this field, and we need to be addressing this regulatory question. And I like how in Marionettes Incorporated, the author addresses it somewhat, right? So let me move really quickly to the next story, and then I'll leave a good chunk for Q&A questions with you guys because I want to do that. So the following story that hopefully you were able to read, and the one that I said was quite a shocker, is I love this story. Remember, this was written in the 1990s. It feels like it was written yesterday, right? So the 1990s means that this was before we had Facebook, before we had Skype, Instagram, TikTok, I don't know, all the different photo stuff, Twitter, et cetera, et cetera. And really, he nailed it, right? So a little bit about the author. So he is one of our, is he our only living author, actually, of everything we've read? So he's well, and he was born in 1968, and he lives in Tijuana, Mexico, and in San Diego in the US, in California in the US. And I don't know if he's still completing his PhD, but last I looked, he's at UCSD completing his PhD in communication. So he's one of the older individuals who, you know, later in life decides to go and get that PhD. So what's fascinating about him is that he's written many, many, many stories, all types, short stories, essays, different types of fiction. And I mention this simply because I think as somebody who is talking about technology and the media and journalism with his particular story of Gray Noise, he has written for TV, he has written for different types of media and theatrical production, so he's somebody who's in that world. And he also designs comics and is in the performance art world, so he's someone who is not just in the literary genre, and we can see that, I believe, really in this particular work and in many of his works. He is one of those writers who is bilingual, English-Spanish speaker, and he apparently tends to write more in Spanish with respect to his science fiction and horror works. So Gray Noise or Ruido Gris was originally written in Spanish. And so we, of course, read the English translation. He is the co-founder of an indie publishing firm called Pellejo Molleja. And wonderful because this particular publishing firm is all about editing and publishing, you know, and editing different types of subgenre literature within the science fiction world and science fiction comic world. And so you can do a really quick Google search on his name and you'll see he has some really interesting graphic novels that he's done. And so totally check it out. And so, but the reason why I have us read him is, again, I wanted to close our series here, kind of sort of returning to the Americas in a way, but not to the United States, and somebody who lives between the US and Mexico, and just to see this, to hear another voice perspective. And he is one of those who really looks at science fiction as a way to express his and just in general human social reality. So moving to the particular story we read this week. So Ruido Gris is the original title. It actually won a very well-known prize in Mexico known as the Calpa Prize, so for the best science fiction story when it came out. And this particular story is fascinating because, well, what is it about? Well, it is about a journalist that has an implanted camera in his eyes, right? And the idea is that as a journalist, he is constantly looking for events that are going to make news. And what do we mean by making news? Well, it means the more dramatic, the more morbid those news are that he is representing through his camera here, the greater the likes, right? The number of likes. And what that means is more audience and more money. And so it's this continuous cycle. And so what this story does, and again, if you didn't read it, please take them a chance to read it, because he really goes through this cycle of what it means to be recording all of this information and in a way, kind of sometimes from the very traumatic to the very violent to just the plain dumb, right? Or stupid or useless. And so it really, again, this is in the 1990s when he writes this story. So he's addressing this question, what does it mean to have these omnipresent cameras around us? And what does it mean to be a voyeur, right? So what is the role of voyeurism? And as really the only thing that's science fiction in this story is the implantable camera, right? The rest is reality, right? We have cameras everywhere with us through our cell phones, right? Through our laptops, through our, in our cars now, just surveillance systems, cameras are everywhere. I think also another question he addresses quite poignantly is the issue of journalism. And I think it's this issue of, is journalism evolving or is it actually devolving? And what does this mean? And certainly with today and the question of misinformation, false information, where are we at? And he certainly addresses those questions. Also, the idea of the concept of the media. What is the role of the media now that everybody is the media, right? It has the capacity to be the medium to share stories. And then finally, this question of the employer's control over employees. Now, this certainly was brought up in Rossum's Universal Robots, but here, a human being, right, who has this implant paid partially by the company for which he's working for, then what does this mean for, he talks about being in this world of just 24/7. He's on, he's recording, right? And he gets to this moment where it's so much that in the end, he's actually more isolated than connected with people. And so I think this is something that we're certainly feeling and living currently. Right now, as we're getting to the end of class, let me end with this final comment here. So I wonder if by wanting robots to embrace the best human characteristics, like knowing right from wrong, we would create no other option than for them to rebel against their creators, because they will one day realize that they are robots, forced workers who were created with a specific agenda in mind. Correctly. So you're basically saying that, yes, if we end up creating these robots that have our cognitive capacity, then most certainly, because, right, we question each other, right? We debate each other. We understand each other, and we also misunderstand each other. So of course, if we're creating this type of intelligence for these robots, they most certainly will have those questions about themselves and back to us, right? If they haven't already destroyed us, right? So thank you again, everyone, for participating. And I will see you next week. Have a wonderful rest of the day or weekend and week. So thank you again very much.